Now, I know it's been a while since the last episode of our Fallout Power Armor. And if you've been following our channel, you know that's because we've been putting all of our time and effort into this, the Smith Blade. The Smith Blade is our 21-in-1 multi-tool, and the shop has been going through quite the transformation since the success of our Kickstarter. So we haven't been able to focus quite as much time on the Power Armor as we'd like to, because all of our engineers and hosts have been pulled into manufacturing the Smith Blade. Throughout this series, we've managed to make a power pack strong enough to operate the entire suit, exoskeleton arms able to curl 300 pounds, a fully decked out helmet complete with heat and night vision, and we've even tested the capabilities of bulletproof armor. And then we put it all together with exoskeleton legs to support the entire suit's weight. In this episode, we're tackling the Pip-Boy. Let me explain. In between transforming the shop and getting ready for the knife manufacturing, I've been preparing the armor pieces to be nanovated. Now, this process is going to take a lot of time. There's a lot of pieces, and it's a slow and intensive process. So, in the meantime, the co-ops need a project to work on. So I thought that this would be the perfect task for them. If they can't work on the power armor directly, we want them to work on something that will enhance the project further. Take it easy on these guys. This is their first Hacksmith project, and we're excited to see what they can do. And without them, you probably wouldn't have gotten a power armor update for a while. This is Tristan and Andrew, and they'll be building the wrist-worn computer, the iconic Fallout Pip-Boy. Andrew is going to handle the mechanical, while Tristan is going to handle the software and the electrical. We want this to not only work, but also be seamlessly integrated with the Fallout Power Armor and allow our Squire to assist.
Caleb!
No, I'm not touching.
Can you stop inflating, please? It's starting to crush my lungs.
I just hit the button, I'm sorry.
In the game, when you open the Pip-Boy, time stops. But obviously in reality, we don't get that luxury. So that's where these come in. This video sponsor, the Even Reality's G2 and R1. They're augmented reality glasses that are meant to enhance the everyday. They can translate conversation, take notes, act as a teleprompter, monitor your vitals, and help you navigate. That sounds familiar, right? What's cool about them is that the HUD looks extremely similar to the Pip-Boy menus, and our goal is to make everything communicate together. So our new Squires are going to be well equipped for the wasteland. Now, here's my list of the project requirements. Yeah, good luck.
I was tasked with the mechanical design. This is the Pip-Boy 2000 Mark VI from Fallout 76. We chose this one and not the newest Pip-Boy because of its mechanical complexity, making it a really interesting build. It's also a little bit bigger, so we have more room to incorporate various components. So Bogdan gave a whole list of features to implement into this Pip-Boy. So I've split the Pip-Boy into various assemblies to show its functionality. Firstly, we have our screen enclosure. This is where the Raspberry Pi is, the LED screen, and most of the electronics. It was really difficult to fit all the electronics that we wanted in here. This Pip-Boy is going to be a little bit bigger than the canonical in-game version, but that was necessary just to fit everything that we wanted inside. So the next assembly we have here is the camera box. This is where our camera that's running VATS is going to be stored, as well as our battery, which will power the system. So our next assembly, and personally my favorite, is the holotape assembly. The holotape is the in-game data storage device and is kind of like the Fallout version of a VHS tape. This assembly includes a tape deck, which will drop down and which you can insert the holotape into. Also, as you'll see on here, we have a mechanical counter clock. So the mechanical counter design was actually inspired by an abandoned gas pump I saw while on vacation over the summer. I thought it was really cool, so I'm hoping to implement it into this design. So in our last assembly, firstly, we're gonna have a Geiger meter. In addition to displaying the radioactive levels on the Pip-Boy dial, we're also gonna attempt to display it on the Even Reality glasses. We're also gonna have a radio, which you can change the channel of using a knob. It'll display the channel using a linear dial, and we have a speaker so that you can hear all your favorite tunes. We're also gonna have lit up vacuum tubes for aesthetics behind this mesh. And then lastly, we're gonna have some knobs and dials so you can actually interface with the Pip-Boy menu. I've got a lot of steps ahead of me. I've got to 3D print all the parts, assemble them, make sure everything fits, paint it and make it look nice, and hopefully it's ready by the time Bogdan needs it. Okay, now I'm gonna go.
Where are you going?
No, should I keep going?
Yeah.
Okay.
Let's go. You go make the Pip-Boy.
Okay, okay. Wish me luck. Bye. Okay, I gotta print everything in here, so yeah.
So, I've been tasked with developing the electronics for the Fallout Pip-Boy. In order to do this, I'm using a Raspberry Pi and a teensy microcontroller. The Raspberry Pi is the brains of the Pip-Boy. It controls the screen, it does the AI processing required for the VAT system, it handles the map, etc. The teensy microcontroller is used to listen to the button responses and to control the radio, and it communicates via serial to the Raspberry Pi. And as you can see, we can navigate through the various menus. For example, I can go and access the inventory menu, and I can go and scroll through there. So we can see the different items in here, including the Smith blade and the power armor. Then we can also go to the data menu. And through here, we can access a variety of useful menus, including the maps menu, which allows us to get a little map here of Hacksmith Industries. And you can zoom around and pan. In addition to that, in the Fallout games, there's these holotapes. And now these are similar to little drives that you would find around, and they contain various data in game. So I have a couple of mock holotapes here, and we can show how they interact with the Pip-Boy. So I have a USB stick here that simulates a holotape, and I plug it in. The Raspberry Pi would detect that. Once that's done blinking, we can go and enter it, and what do you know, it pulls up Pong. So you can play Pong here. Oops, may have made the AI a little too hard. Now we also have another holotape, and if I go back to the holotape page, it pulls up the Hacksmith store. Got the mini saber, got the Smith blade, hacksmith.store, check it out. And we've also got a radio page, just like in the game. So if we go to the radio page, we've got a bunch of different Fallout stations here, and we can use the radio dial, just like on the actual Pip-Boy, to tune through the stations and then find something to listen to. One of the hardest technical challenges of this was actually developing a real working VAT system. So in order to show you guys that properly, let's get a bigger screen. So I can go into the VATs menu, and it pulls it up. And now if I want to take a shot of Owen, gets a good image, and I can scroll through all the different options here. Now there's a big number on each one. That is the hit chance, and the way that is calculated is that is the AI model's confidence level that is actually Owen's head or his torso or whatnot. And just like in the game, you can scroll through all the different body parts, and it'll tell you the hit chance for each of those, and then you can select one, and then you can target it. Now, some of you might be wondering how you can build your own VAT system, so let's go through that. Under the hood, VATs is actually running 2 separate AI models. These models are publicly available, and you can get them from like OpenCV. The first model is a segmentation model. Now this goes and highlights all of the pixels on the person's body. So it just identifies the person, highlights all their pixels. The second model is a pose model. This is the one that draws this skeletonized pose out here. So it just identifies where is your shoulder, your elbow, your wrist, etc. And as a result of this, I know where each body part is. So then I go and take the points that like correspond to, say, the left arm, for example, and then I draw a little bubble around it. I go and look at all the pixels that are in both the segmentation model and inside that bubble, and that gets me all of the points that are highlighted for the left arm. Same for the leg, etc. So with most AI applications where you have like a camera and then you have like a video and live drawing boxes, there's 2 steps in there. The first step is that there is something that actually processes the image or video and that outputs some form of feedback. And then you run a script based on that feedback to then draw graphics as a result of it. So the models you can find publicly online, but all of the stuff to like draw where the bubbles are and like draw the skeleton stuff is stuff you have to like write on your own later. And that's how you get that.
Okay, so I've colored up the model. Looks really nice. I finished up practically everything. I've added the decals, and I think that I'm gonna start printing stuff off. The exterior shell I'm gonna print out of ABS, and then the rest will be printed out of materials like clear resin for the vacuum tubes, and also some carbon fiber filaments, just to make sure that some of my parts don't break. Yeah, let's get printing. Okay, so I have all my parts ready to be printed. They're all in the slicer, ready to go. I'm printing with a bunch of different colors, some different filaments. Yes, I'm using a lot of printers here. I'm using this one, this one, this one, this one, and this one, and then one of those ones. So hopefully, I don't know, like a breaker doesn't flip because I'm drawing too much power, something. Wait, please close the door. Okay, I don't know what that's gonna do.
So since the Pip-Boy is on your wrist and you can't always be looking at it, we've also added a HUD onto the Even Realities. Now coincidentally, the HUD is also Pip-Boy green, which is real nice. Now the HUD itself contains a few components. There's some health monitoring, which is done through Even's R1 ring. So this ring interfaces with the glasses, measures your heart rate, it can handle your interactions, it talks to the app on your phone, which then sends the information back to your glasses. Additionally, there's navigation features to integrate with the map on the Pip-Boy, where you have a map on the even realities that links to the map on the Pip-Boy and allows you to see where you're going as you navigate, and a fully functional Geiger warning system, where if the Geiger counter detects radiation levels too high, it warns you about them. So if I take the Smith Blade Tritium here and hold it up to the Geiger counter, should get a pop-up, which tells me that the radiation counts per second is too high and it tells me to evacuate the area. The way the Geiger warning system works is you have the Geiger counter itself. You have particles of radiation. It counts every time a particle of radiation hits the Geiger counter. Now each time there's gonna be a voltage across here. We detect that voltage at the microcontroller. This then determines from the number of voltage, like spikes it receives, how many counts per second we have. It sends those over USB to the Raspberry Pi, which then, if the counts per second is too high, sends a Discord message. That's the Discord icon. Don't question it. Which is then received as a notification on the phone, which then gets sent to my even reality glasses. And that's how I stay safe.
Right here I have my SLA print ready. One is the mold for the screen cover. We're gonna try to get it to look like a CRT screen, which has kind of that rounded cover. And the second part here is a bunch of vacuum tubes. This is just for aesthetics. We're gonna put an LED in here. Okay, so this has been printing. Let's go check it out. Okay, so we made it upstairs. Parts look good. At least the screen mold looks great. So this is actually my first time using the Formlabs, so nice, okay. I think, yeah, the first step is to yeet it in there. It actually looks pretty cool. Nice. I realize now I could have put threads on this, but yeah, I don't usually do threads on 3D prints because they're 3D prints. Oh, that's nice. It's so smooth. Well, it's pretty smooth actually. I wouldn't say it's totally smooth. Now I'm gonna throw this into the UV curer. How do you turn it on? It's in Chinese. I don't know like the labels. Oh yeah, it's on, okay. We're good. So now I'm gonna put on some semi-gloss, what is this even called? Like a clear gloss finish to make it look nice. It's also just gonna help smoothen it out a little bit. You know, the glossy clear coat seems to have added some nice, you know, reflectiveness. Overall, it looks pretty good. In order to create the various aesthetic parts of Pip-Boy, I'm gonna be using the Eufy Make colored resin printer. This can print on pretty much anything, even these 3D printed parts. And the cool part is along with printing in full color, it also allows you to print with texture, allowing your parts to kind of pop out a little bit more. So the Eufy Make's pretty simple to use. I'm just gonna drop my part onto the build plate. I'm gonna move my picture onto the software. I'm gonna realign it and size it. I'm gonna choose my texture and hit print, and hopefully we get a nice part. That's actually so good though. The texture, so satisfying. So, my parts are done. Let's see how it turned out. Look at the parts! Woo! So here are my parts, they're ready to go. Let's take them apart.
So now that we've figured out how to tap the Geiger counter electrically and gotten it connected to the even realities, I'm now gonna wire everything here up and hand it off to Andrew for the final mechanical assembly. So I'm gonna start off with soldering the buttons for the menu pages. So those are the buttons. This is one of the dials for the menu. Okay, how are we gonna do this? So this is the switch to turn on the radio, and when the radio goes on, we need the vacuum tubes to light up. So in order to do that, the microcontroller detects either of these presses. But in order to turn on the LEDs, I need to connect the LEDs to this switch as well so that they turn on when the radio's on. Here, we got the little LEDs for the vacuum tubes and the mount that they go into, so I'm gonna pop that in. Now I'm just gonna solder all the radio stuff together, so that's the radio tuner, the amplifier, and the speaker. My speaker is smoking. I don't know if this is a good thing. You know what, it's electrically connected. Would I put this on a rocket? Probably not. So now that we've got some of the soldering done, all that's left to do is more soldering.
Yeah. Hey.
Between you and me,
Sure.
do you think the co-ops are going to finish on time?
They've already not finished on time.
Yeah.
Do you think they're going to finish on time? On
No.
December 10th?
No.
I think they'll get it done, but I think there'll be a few more imperfections that still need to be worked out.
December 10th.
10th.
Is that because we have a sponsor deadline?
No, that's my deadline.
Good idea. You always gotta give the co-ops a fake deadline because that's the only way stuff gets done.
It's a real deadline, not fake.
Just between us. It's
Yeah,
a fake deadline.
and the audience.
Well, assuming it's a fake deadline, then yeah, I think they'll be done by the 18th.
I've got all my components for the Pip-Boy done and ready to go. Now that Tristan has handed off the electronics, I can start assembly. First step is to mount the screen. Perfect. And screw it down. The next step will be mounting the Raspberry Pi on top of this purple 3D printed mount. Now that the Raspberry Pi is on, I'll be mounting the HDMI splitter on top with some double-sided sticky tape. I will mount the Geiger counter. The next step will be to mount the buck converter. And last but not least, we have our teensy microcontroller. And there you have it. There will be a lot of wires in here once I hand this back off to Tristan. This will fit on to your arm, like so. Okay, the screen enclosure is done. The next step is the radio box. So this is the main enclosure. This is gonna hold everything. It's pretty small, so it's gonna be a really tight fit. I have all the electronics that Tristan gave to me here. I also cut out like a kind of nice mesh which goes on top, and then the speaker is gonna be pressed up against it. And then to retain the speaker, I have this 3D printed mount, fits in there. In order to move the little ticker up and down, this screw is gonna sit inside the middle of this rail here and act like this screwdriver. So when it rotates up, it's gonna move the rail up as well with it.
Hey, what day is it?
It's Thursday.
December 4th?
4th.
Uh-huh. And what's the date on the whiteboard?
The new one or the, 'cause this is the new date.
No. This one right here. It's time to boogie.
We're boogieing. So the next step will be to, when the servo is plugged in and on, it actually moves the linear dial up and down. Yeah, so I'm gonna plug it in and see how it goes. Yes! It's moving! It's moving. Okay, wait, let's see it from the front view. Oh my gosh, okay, it actually works. I'm really happy about that. I needed this. Turning the encoder with this knob changes the radio channel. This switch will turn on the vacuum tube lights, which are just essentially the lights of the Pip-Boy. They look kind of cool. So I resin printed these. The LEDs are gonna fit inside here and they're gonna light them up. It is in place, it's not coming out. I'm going to essentially plug in the left LED. Okay, yeah, nice. I could probably make it brighter by just turning the voltage up, but honestly, I'm pretty happy with this. Radio box is done.
Let's go take a look at that timer.
Let's hide this. Don't zoom in on that. I am gonna be putting together the Geiger box. I'm gonna be putting in these buttons that Tristan soldered together. This is the little sticker I made with the Eufy colored resin printer. Now it moves up and down okay. I don't think it's gonna be fully done today. I think that would be hard. But tomorrow...
What do you mean? What do you mean?
So Pip-Boy is looking really good, and the only parts left are the holotape enclosure, the holotape itself, and the mechanical clock. Next assembly is the holotape. This is what actually goes inside this holotape enclosure that I just built. There's two dovetails on here, so one here and one here to hold things together. I'm gonna actually slide this up onto here, and there's your holotape. Like so, you just slide it in. I'm not sure. Hello.
What's going on?
Nothing to see here. I still have a minute and 10 seconds, 11 seconds.
Why is it counting up, Andrew?
It's definitely not because the timer went out and now it's counting how much time has finished after the timer has gone off. We're in overtime.
This is the time to lock in.
We're locked in. Okay, mechanical assembly will be done by end of day. Big claim, big claim. If I'm wrong, you guys know. This is the clock I designed for the Pip-Boy. It's a bunch of interlocking gears which slowly make their way up from the minutes to the years. All these gears are unique, which made the design very, interesting. To drive all the gears, there's a little mechanism which is being controlled by a servo motor. All I need to do now is assemble all of this into this chassis and put it on the front of the holotape holder. Okay.
They're going in?
Yep, they are going in. Now that the clock's done, I'm gonna hand some of the components off for painting, and in the meantime, I'm gonna do some finishing touches on the Pip-Boy. That includes working on the leather cuff, working on the metal grating around the vacuum tube lights. We'll be done by end of day. If I'm wrong, you guys know.
So now that I've done this,
That's AI, I never said that. No.
Full day and overtime.
Uh-oh. What happens?
You get really miserable and stressed out.
No.
and then I need to connect this wire with, we'll see. Oh, what did we blow up? I'm just gonna poke around, see if I can figure out where the short is. I know it's in the radio box somewhere. Yeah, I was careless and I guess I thought I probed the 5-volt rail correctly. I don't think I did.
Alright, what's the plan? Let's go over. Okay, so Geiger counter still works. Raspberry Pi's gone, Teensky's gone. This is probably gone considering it was on fire. Most of it is going to be hoping it replace whatever components are broken. Little concerned about the screen. This is the only screen we have, so I'm going to go test to see if it's also fried.
That's the one thing that, if it's gone, may not come in on time.
Let's think about plan if things don't work out.
The video's supposed to come out on the 18th. Okay.
Which is in 3 days.
Yes. Our sponsors are expecting it on the 18th.
Okay.
Well, so if I can go screen.
No way, let's
Okay,
go!
we're still back. We have everything we need. I just need to
So back! Oh my god.
We're gonna be okay.
Okay.
At this point, these guys just have to finish it. Mechanically, I know that we're not. We're basically there. You have to reassemble a clock today.
Yeah.
It's this stuff I'm a little worried about.
How long do we think the wiring will take from now, like given the...
If I have the components, it will be done before you guys come in tomorrow morning. Let's go. Everything's on. Okay, that's good. Green light on the Pi. That sounds like a servo moved. We've got backlight from the screen.
Yeah, it's a radio, that's good. Yeah.
That means that the microcontroller works. Can I turn the Geiger counter on?
Hey, let's go.
Okay, so I have the servo pin out wrong and I need to fix the HDMI, but that's a lot better than it was yesterday.
That's good. We can work with this. Pip-Boy is pretty much done. We have put it together. It looks amazing. And yeah, it should be ready for tomorrow's test. Let's see, let's check how we're doing with this deadline. Yeah, we got 5 days to go. Jokes.
Ignore that it's counting up.
Yeah. So video is supposed to come out tomorrow, actually.
Oh, we're so screwed.
Okay.
It's so over.
Okay, so the day has come, just on time. Not
6 day?
Yeah, we have 6 days.
It's not counting up. Oh. It's not counting up.
Definitely not. Yeah, it's been definitely a really fun project. Tristan and I have had a lot of fun with it. We're really happy with how it turned out. It has some quirks, but they're kind of fun. It is kind of like you know, a pretty rugged, like wasteland type vibe. So it only makes sense that some stuff doesn't really work, right? Okay, so for the big reveal.
And go. This is it. We present you the Pip-Boy from Fallout 76.
That looks awesome. That looks like a really good replica, honestly.
Yeah, in terms of the mechanical stuff, one of the most challenging parts was just fitting all the electronics inside. I don't know if you guys can see from the side, but like the backplate doesn't even fully go on because of like how much is inside. But you know, that's definitely purposeful for like, you know, ventilation purposes.
Right.
I didn't, You know, the aesthetics turned out really well.
So is that a fully mechanical clock?
It is a fully mechanical clock. Yeah, it does jam a lot. So this is one of the quirks.
All right, let's turn it on.
Yeah.
Power button's over here. Just gonna.
Ooh, I like the loading lines.
That is, I'll be honest, that is not intentional. That's just my crappy HDMI connection.
That looks so good.
Yeah.
So we've got a few different menus here. So we've got like the item menu. So we've got like the full inventory of all the bunch of different things. You got the power armor, got the smith blade. Got a data page. We'll go through that in a bit. You've got like a map. You've got VATs. You've got notes and the holotape. And we also have a functioning radio. So if I turn this on, and as we scroll through the channels, I don't know if we'll be able to tune anything, but you can see that the dial indicating what frequency you're on is changing. And we're scrolling through the little full radio stations.
So sorry, that is actually an FM radio?
This is an actual FM radio. So yeah, if we go back over here, the other features that we've implemented is we've implemented a Geiger counter. So if I turn this on, pop on the Geiger counter, and if you see here, it's actually like showing the counts here. So we actually scaled this up so it shows the counts on here as they happen. So this is just showing counts per second, but basically as it changes the value. And as you bring it close, if you bring it near the bottom here, radiation goes into the red side a bit.
Oh, there it is. Yep.
Whoa! Is that a servo motor? That's there we go.
Nice. Yeah. Wait, let's go. Okay. Here, Bogdan, check it out.
So we actually hooked it up so in the event that the radiation's too high, it should pop up a notification warning you.
Oh yeah, I got it.
Oh, you got it?
Yeah, Discord notification, Pip-Boy Geiger counter warning. Radiation CPS is equal to 7. Please evacuate the area.
Oh my gosh,
Wait,
yes.
so you're literally using the Discord API to send notification. That's really clever. I really like that.
I gotta give credit to Charles for that one.
That is
his
a
idea.
really smart way to integrate, you know, a custom system with something that's an actual product, and it works really well. That's awesome. Honestly, it's working better than I thought it was. Yeah. Having seen how much
Glad to know you're a believer, Bogdan.
having seen how much you guys were stressed 2 days ago.
Oh my gosh.
And then also, if we want to demo VATs really quick.
Yeah.
If I pop into VATs, Andrew, if you want to stand
I'll
behind
be
the camera.
I'll be your test subject.
And now we can,
Oh, sweet.
we got a full targeting system so you can see exactly
That's awesome.
exactly
Wait,
how
so
to target
what
every
does that
circle.
number actually mean?
So this just represents how confident the computer vision model is that that's his actual torso.
Okay,
So the idea is
fair
that the confidence of the computer vision model is kind of like related to how obvious it is in the image. So it's like how easy it is to target as well.
Fair enough.
Which would actually work, because like if you had half your arm blown off, it might
Yeah.
only be 50%
that's true,
confident
actually, yeah.
that you have 50% of an arm, which would be a 50%.
If you're actually using this to aim, if you're like halfway behind a wall and you can only see half of your body, then like the chance of you hitting the body trying to shoot at it is 50%. I like how his health is already at 0.5%. I'm guessing that's just because of all the overtime you guys put in.
lack of sleep.
Lack of sleep, yeah, that would do it. Yeah. And then I think the last thing was, so we have the holotape as well, right? So the holotape, which right now the one loaded is a little Hacksmith store.
Oh, that's awesome.
Embed in here, so you got like a little Smith blade ad. So we got that feature
You got
here.
another holotape?
And then if we switch it out, Andrew, do you have the other holotape on there?
So I have another holotape. I think I do. There's so many pockets.
This has been the entire project for the record.
It's another holotape. It has like a little USB in here with some pre-flash firmware.
How do you know which one's which? How do you know?
You don't.
You have to open them up.
Slide in as far as you can.
Yeah, that's perfect. And if we open up the holotape again,
So hopefully this works. Yeah.
you get a little game of Pong. I have never beaten this AI, actually. Unfortunately, I think I made the AI too good. Oh, the maps
Oh,
work
the
this
map's
time.
working. This is sweet.
Yeah, that's right where we are.
Yeah, so you have Hacksmith. Yeah.
And sorry, can we scroll around too?
If you press the button in, you now are in like panning or vertical, and then if you press it again, you're panning horizontally, and then you just keep
That is
toggling through the
awesome.
modes.
So I do have to say, I love the consistency of the entire UI. All the different mini games, all the menus, the map, and obviously the even realities, having like that green holographic overlay. It looks so consistent and so Fallout. I love it.
Yeah, the map here even like looks like the even realities map. So like if you use the navigate feature as well, it pulls up like a map projection in front of you that's also green scale, which is really nice.
Bogdan, you want to try it on?
Sure.
To put it on, the first step is to just kind of, put down the holotape. So there's a little mechanism in here. You just press these two push buttons.
So it actually closes in.
It actually closes in and locks in place. So to slide it on, this is
left hand
kinda,
or right
yeah,
hand?
left.
Oh, yeah, that's good. That's good. Okay,
and
tighten
then
it.
tighten it. Yeah.
How long does the battery on this thing last?
In theory, like 20 to 30 minutes.
There's a nuclear core in there. It'll last you about, it'll last you a good 100 years.
right?
Yeah.
You got the weight of the Smith blade wrong. It's actually not 0.5. It's actually 0.09.
Oh.
Why am I only level 6? Is that how poorly?
Because you haven't really been around.
Is that how
like,
poorly you
that
think
much.
of me?
Yes.
Sorry, Bogdan.
This is pretty sweet.
Yeah, this is awesome. Great work, guys.
I do wish it was a little lighter. My
Oh,
shoulders
I know, it is actually pretty
definitely
heavy. Yeah.
There's a lot of like metal and
You
like
kind of need to
glass on
support
here.
like your.
Yeah.
Oh yeah, try vaxing James. Yeah.
Oh, that video feed is very smooth and very low latency. That's actually impressive on its own. All right, let's try this. Oh yeah, 80% head, 79% body. I love the highlighting too. The highlighting works super well.
That's awesome.
Apparently James has a lot more health than you do.
No, it knows. It's going off of sleep.
James, left leg, right leg, head, chest. Okay, so the last thing that I want to see is I was promised that you could stream video from that helmet to the Pip-Boy.
So the problem is,
You can.
that's what the video looks like. The wireless HDMI works with the power armor onto like another monitor, but it doesn't work on this monitor.
So that might be a really, like, that could just be a resolution fix on the power armor side.
Yes, I think
But-
that you may be able to just change that on the Jetson.
All right, you want to try it on? Oh man, that thing is quite the workout.
You're dead. Oh wow, that's awesome.
That is like instant. Like you click it and it's like, there's the head.
Yeah, I love how you faded out the background too.
It literally
Really
looks
cool
like it's in
touch.
the game. Like it freezes the image and then like blurs it out, overlays it, and it's even got the scan lines and everything. It looks so good.
Hey James and Bogdan, I just want to say it's been a great co-op. This Pip-Boy was a bit of a challenge, but Tristan and I pulled through. This place has been awesome.
Are you reading from a teleprompter?
No.
I was wondering why you're being so awkward.
Yeah.
Honestly, this thing is super, super cool. I cannot wait to take all the features you put into this and actually get it integrated into the suit. Because, I mean, the end goal is to be able to have, you know, the scribe help out with...
Squire.
Both because like the end goal of this is basically to have the Squire be able to help me get suited up. So if you remember me yelling at Tyler, trying to be like, hey, I need to like, you know, can you inflate the cuffs and help me with this and adjust this? Now the goal is to be able to use the Pip-Boy to control the entire suit and actually make it more useful and usable. So this is such a great, cool project, and you guys really pulled through on it.
Yeah, awesome work, guys.
Thank you.
Let's get that wireless HDMI working, and then be pretty
That'll be
sweet.
exciting.
So one of the reasons we asked to do that is in the future, if we take the power armor to a convention or something, we can't exactly let everyone put the helmet on because it'll probably get broken fast. And so being able to have this show what the person or whoever's in the power armor sees is a great way that we can let you kind of experience what the power armor's like through something that you can actually get up close and personal with. So we'll have to get that working before you guys leave. But besides that, like, you guys knocked it out of the park. This was awesome.
Thank you. It means a lot.
Yeah,
James.
it was really fun.
All right.
Yep. Hey!